In our lesson today, we're going to review unit multipliers. There's one in this list we're going to review that may be new for some of you. Many of you have been using it in science for quite a while, so it'll be familiar, but we want to make sure everybody's on the same page with it. And we'll do one example that's just a straight multiplier problem that uses that particular unit multiplier to convert. Most of the time we're going to spend talking about angular velocity, which is things like RPMs, revolutions per minute. And then we will also need our unit multipliers as we do some of those. So first, let's review some of our multipliers. And inches and feet, Paul, how are they related? How many of one and the other? So 12 inches in 1 foot. What about feet and yards? How are they related, Olivia? So 3 feet in 1 yard. What about feet and miles? How are those going to be related? How are they related, Allie? So 80 feet in 1 mile. What about centimeters and meters? Let's do a little bit of metric in here. Anna, who's our metric expert, because that's mostly all they use in Europe. So 100 centimeters in 1 meter. What about liters and milliliters, or meters and millimeters? How are they related, Noah? So 1,000 milliliters in 1 liter. And here's the one that may be new to some of you. That's why it's got a star, to make sure you know this. So milliliters and cubic centimeters. One of those is cubic units, and the other one isn't. How are those related, Luke? So 1 milliliter is 1 cubic centimeter. So if you imagine something that's 1 by 1 by 1, that's 1 milliliter. So many of you know this from science. If not, this is one you do need to memorize. And what if we want to go between English and metric systems? What do we have to do with that one, Kane? So 2.54 centimeters in 1 inch, and that's one where we only use 2 places on it. And finally, for time, what are some of our multipliers there going to be? Samantha, seconds and minutes. 60 seconds in 1 minute. And everybody, how many minutes in 1 hour? So most, if not all of those, should be familiar. So let's do this quick review that does use that one that might be new for some. So we have 25 liters. That starts off in the numerator. We want to change that from metric to English. We want to end up with inches, so we know we're going to have the 2.54 centimeters in an inch. So that tells us, oh, we need to change the liters so that we can get that where it is in milliliters, so we can change the milliliters to centimeters. So what multiplier do I use next, Gavin? A little louder for me, please. So 1 liter in the numerator. So 1 liter in the denominator and 1,000 milliliters in the numerator. And now I have milliliters. Now I can use that new one, milliliters in the denominator, to cancel cubic centimeters in the numerator, and that was 1 to 1. Now I could change my centimeters to inches, so I need centimeters in the denominator to cancel. Inches in the numerator, 2.54 centimeters in 1 inch, but I had cubic centimeters. So instead of writing that out 3 times, we know that that's the same as cubing the 1, cubing the inches, cubing the centimeters, so they'll cancel, and most importantly, cubing the 2.54. So then we write that neatly, 25 times 1,000. Don't need to write the ones. 2.54 is cubed. Did I get everything written down there that I needed to end up with cubic inches? Did I leave any of the numbers out? And who has already punched that in on a calculator for me? And what did you come up with? So 1,525.594. Did others get the same thing as Amy? And there is our approximate answer. Questions with that? Okay, now let's start talking about angular velocity. So raise your hand if you've heard of RPMs. Anybody have a good explanation of what those are? Look, it is revolutions per minute, rotations per minute, one time around per minute of something. And where do you often see or hear about revolutions per minute? In cars. And so that has to do with how often something inside the engine is going around. And I'm not a car mechanic, so I don't really know what that is. So that we usually hear it in the engine. We're going to mostly be talking about it today as far as how fast is something moving down the road or moving across the room. So let's think about, instead of things inside the engine turning, let's think about, a car's got an axle, right? And actually, a car's got two axles, two wheels on each side of it. Think about maybe that axle spins around, let's say, one time in a second. And then you've got your wheels out here. If you have a small wheel and it turns around one time, you'll go a little ways along the road. If you have a bigger tire and the axle still just turns one time, will you still go the same distance down the road, or farther or shorter? What do you guys think? You're going to go farther because of having the bigger radius. And we usually then, when we talk about how fast we're going down the road, we usually don't say, oh, the tires were spinning one time per second or 20 times per second or whatever it may be, because cars would have different size wheels, and that would quite honestly probably drive the state patrol nuts, because if we were going by RPM, some of us would be going faster and some slower because we'd have different size tires on there, and they need something the same. So they talk about the linear velocity, and we are used to using miles per hour for that. Today, we're going to talk about converting back and forth between the two. So first, what I just said, angular velocity is how many times does something spin around in a certain amount of time. It's technically a vector. It's got both direction and magnitude, and it's always going to be measured in some kind of way of saying going around. It might be revolutions, it might be rotations, it might be degrees, it might be radians, some way of measuring how far around you're going per time. So you could have all kinds of things like any of these. You don't need to copy all of those down, but you need to understand it's some amount of turning per time. Whereas linear velocity is how many inches or feet or meters or kilometers per unit of time. The formula that we are going to use that you need to memorize today is V equals omega R. That is not a W, it's the Greek letter omega. V is the linear velocity. V is things like miles per hour, feet per second, distance per time. Omega is the angular, it's spinning per time. The trick with this formula, we can talk about angular velocity away from this formula in degrees per second. We can talk about it as radians per minute. We can talk about it as revolutions per second. But in this formula, we can only talk about it as radians. So if they say it is going, it has an angular velocity of so many revolutions per minute, before we can plug it in here for omega, we have to change it to rotations. If we use this formula and we know V and we're trying to get omega, our answer will be radians. If we want something different, then we have to convert it. That's the hardest part of this whole formula. And since sometimes, but not always, we need to convert, we need to have a multiplier for converting between angular velocity, between revolutions and radians. But you guys really already know that. How many times around the circle? So one revolution is how many radians? One time around the unit circle is 2 pi radians. So that is our unit multiplier. We can use one revolution over 2 pi radians, or we can do 2 pi radians over one revolution. And if we happen to have it in degrees and need it in radians, we already know that multiplier. We know that 360 degrees is 2 pi radians, except we simplify that to 180 degrees over pi radians, or pi radians over 180 degrees. And you already know those last two. So, as I just said, in the formula, we have to be talking about radians. If it's something different, we have to convert. In addition, when we talk about the sine of pi over 3, do we write out sine of pi over 3 radians? We know we don't have to write in radians. We could say that, but we don't have to. So radians we can write in or not. If we have radians showing up as something extra, we can just go ahead and cancel them out, because we already know that if it's not in there, it means radians, and so we can drop it if that makes it simpler to talk about. So let's do a couple of examples here. So we have a wheel of a wagon, and then we've got a radius. It's revolving at 30 revolutions per minute. So that's our angular velocity. And we want to know how fast it's moving in miles per hour. That's our V. So always start by writing down the blank formula, V equals omega R. And then we start plugging in. So they tell me that omega is 30 revolutions per minute. Oops, I can't use the formula because it's revolutions. If I want to put it in the formula, it's got to be in what? Radians. So I need to change those revolutions to radians if I want to use this formula. So I need to get rid of my revolutions and make it radians. And we know one revolution is 2 pi radians. So now I've fixed omega to be able to use it in the formula. I still need R, and I'm going to say, read carefully. A lot of the time they give diameter. Which one do they give now? Radius. So I can just plug in the 18 inches also in the numerator there. Now I've plugged into the formula. And that's going to give me radians, which I can drop if I need to, inches per minute. And I need miles per hour. So we don't need the radians in there, so we can drop that one. And now let's make this a regular unit multiplier problem. We need to change the minutes to hours and the inches to miles. Does not matter which one you do first, as long as you get both of them done. So let's go ahead and get rid of the minutes, since it's all the way over there on the left and I don't want to forget it. And Grace, what multiplier should I use first for minutes if I'm trying to change them to hours? 60 of what is what? So 60 minutes is 1 hour, and now I have the per hour like I want. Now let's worry about the inches. Rhea, how do I start changing inches to miles? So 12 inches and 1 foot are the same distance. I need the inches in the denominator, so it will cancel. And now I have feet. And finally, what do I need to do, Sarah, to change the feet to miles? And then let's write it cleanly because I always expect that so I can easily check your work if you left something out. So make sure I get all of these. We've got the 30 times the 2 pi times 18 times 60 in the numerator and 12 and 5280 in the denominator. Does that look right to everybody? Did I skip anything? And that leaves me with miles per hour. And please punch that in your calculators for me. Jack, what'd you come up with? Thumbs up, thumbs down. Anybody else? 3.213. See several thumbs up there. And that was then miles per hour. Not very fast, but then again, it's just a wagon. And I remember when I would pull my kids in a wagon, I didn't go very fast. Anna? No, because a lot of them won't have pi in there. Anything else on that one? Okay, let's do one more together, and then I've got a couple I'll let you guys do for some practice. Okay, automobile, wheels, traveling, we want angular velocity. So this is a v equals omega r problem, so I start by writing down my blank formula. For this one, they tell me 60 miles per hour. They tell me the v. I need the omega. So first thing I'm going to do, since this is a unit multiplier, I'm going to get omega by itself, since it's a unit multiplier problem. So if I divide both sides by r, omega is v over r. Then let's plug in the 60 miles per hour. We don't want to write that as mph. We want to clearly write it miles in the numerator, hours in the denominator. And then we need the radius in the denominator. So is the radius 28? Kane, what's the radius? 14. Got to read it carefully. And then we'll put the 14 inches in here. And this is automatically, because I'm using the formula, this is automatically, omega is some kind of radians, which I can write in there or not. For now, I'm going to put it in there. I know I can always cross it out if it's not helpful. Okay, notice I have miles and inches in there. Those are both units for distance. I need to get those to cancel each other out. And then I will have radians per hour that I need to change to revolutions per second. So let's get rid of the miles and the inches first. So who can give me one multiplier that starts converting the miles and or the inches? Doesn't really matter which one we want to start with, Dylan. So 12 inches in the numerator, so it will cancel the inches in the denominator, is a foot. Now I have miles and feet. So Macy, what other multiplier do I need? So 5280 feet over 1 mile, and the feet cancel, and the miles cancel. So now I have radians per hour. Now I need to change the radians to revolutions, the hours to seconds. Does not matter which order I do those in. Melina, help me get started, please. Do you want to do the hours to seconds or the radians to revolutions, and give me a multiplier for whichever one you want to do? So 1 hour is 60 minutes. Hours in the numerator, cancel hours in the denominator. What do I need next, Kate? So 1 minute over 60 seconds, and the minutes in the numerator and the minutes in the denominator cancel. Now I have radians per second. I need to get to revolutions. So I need revolutions in the numerator, and I need radians in the denominator that will cancel the radians that I have in the numerator. Faith, how many revolutions and how many radians? Which means that now we are left with, and make sure I don't miss any of these, 60 times 12 times 5280 for all my things in the numerators, and 1460 and another 60 and a 2 pi in the denominator, leaving me revolutions per second. Did I get all of them, or did I leave anything out in there? Okay, please enter that on your calculators. What you get? Anybody else? 12.005 for the revolutions per second. Anybody with questions on this? Main trick is, if you're talking about the formula, angular velocity must be radians. You can convert it if it isn't, or if that's not what you want to end up with. So I'm going to give you guys a couple of these to try on your own next.